Hello, this is Ms. DV, and today we're going to talk about section 7 of chapter 4. It's just an introduction to coordinate proof. So our objectives today are to position figures in the coordinate plane for use in coordinate proofs. That means just putting the figures where they best work, and also to prove geometric concepts by using coordinate proof. Vocabulary is just coordinate proof. So you've already used coordinate geometry to find a midpoint of a line segment, and then also to find the distance between 2 points, which we did with either Pythagorean theorem or the distance formula. Coordinate geometry can also be used to prove conjectures. A coordinate proof is just a style of proof that uses coordinate geometry. So you're going to be using, the x and y axis. Oops, I accidentally pushed a button. You're going to use the x and y axis in order to... Can I not draw on this without clicking? Why? Huh. I can't get my pen tool to work. There we go. X and Y axis. And then you're going to place a figure on it and then find the coordinates of usually of the vertices. You find the coordinates of. And then you can say things like, the length of each side of a square is the same and things like that. So when we do a coordinate proof, there's some hints at where to put your figure. So let me draw the coordinate axes again. You got an x-axis and a y-axis. And you can keep the origin as a vertex. That makes a lot of sense. Like, let's say you had to do a triangle. You can put one of the coordinates right on 0, 0, and then the other three wherever they tell you, and then kind of keep it in quadrant 1. You could also center the figure at the origin. Like if it's a rectangle, maybe it would make sense to have, and then these coordinates would be like opposite of each other. Like you'd have maybe -4, 2 and 4, 2, and -4, -2, and -4 or +4, -2. You could center a side of the figure at the origin. You can use one or both axes as a side of the figure. So this is one where we most often will do it, and then this if possible. The other ones, you can do that if you want, but it's usually easiest to make 0, 0, the origin, be one of your vertices, and then if you can, go along either the x or the y axis, or even both if it's like a square or a rectangle, in order to make the sides. All right, so in this question, they ask you to position a square with side length of 6 units in the coordinate plane. So probably the easiest way is to draw your x and y axes, or you'll have a graph, and then to put the bottom side along the x-axis and the left side against the y-axis, and then your coordinates, because part of what you're going to be doing is finding the coordinates then. So if it's a length of 6 units, you go over 6 and you put a vertex, and you go up 6 and you put a vertice, and then you go over and up, and then this coordinate would be over 6 on the x-axis and 6 on the y-axis. So you usually will have to find this last point on your own using going down to find the x-coordinate and going over to find the y-coordinate. In this one, they want you to have a right triangle. So it's a right triangle, so it's going to have a 90-degree angle. It has leg lengths 2 and 4 in the coordinate plane. And their hint is to use the origin, which I would too. Now this isn't the only way it could look, because the leg could be along the leg of 4 could be along the x-axis, and the leg of 2 could be up here. And then you'd have a triangle like this. And then again, your job will usually be to name what the coordinates are. So this coordinate would be 0, 0. This one, remember the x part goes first, would be 2, 0. And this coordinate up here, the x-coordinate, x value is 0, and the other y-coordinate is 4. So usually you'll have to name the coordinates as well. All right, so once you have it like this, once you have it in the coordinate plane, you can answer questions. Like you could find the slope of the line, you could use the distance formula to find length between 2 points, you could use the midpoint formula to prove statements about the figure. So here's an example. They want us to prove that the diagonals bisect each other in this rectangle. So your first step is to draw the rectangle on your coordinate system. And they've got the already have what the vertices coordinates of each of those are. So then we connect these points, the diagonals, and we are supposed to prove that the diagonals bisect each other. So to do that, we need to know that this part is congruent to this part and this part is congruent to this part. So if we could find the midpoint of x or dB and the midpoint of AC, then we would be able to find the length from, let's call this O, from O to D and from O to B. So that's kind of our plan. So when we do the midpoint formula, we find that this point is pretty much what it looks like on the graph, 2, 5. But I didn't just assume it was 2, 5. I actually checked it by using the midpoint formula. And the midpoint formula is you take your two x coordinates and you add them together and divide by 2. And you take your two y coordinates and you add them together and divide by 2. The great thing in this problem is that some of your x and y coordinates are 0. So it becomes a very simple little problem to solve. Then your next step, now that you know the midpoint, is to, oh, they say you don't have to do the next step. I was going to say now we could find the length of this using the distance formula and the length of this using the distance formula. But they say that actually we don't have to do all that because since the midpoints are the same, the diagonals bisect each other. So we can just stop at that point then, which saves us some time. Okay, a coordinate proof can also be used to prove a certain relationship is always true. So that one that we just did, if we didn't know the certain coordinates for this rectangle and we just said prove that the diagonals of a rectangle bisect each other, we could do that with a coordinate proof too. It's a little bit trickier. What you have to do is assign coordinates, like variables, to the vertices. All right, so this one says position each figure in the coordinate plane and give coordinates of each vertex. So they want us to do a rectangle with width m and length twice the width. So we don't need numbers on the x and y axis anymore. If they're there, you just ignore them if they're on your grid already. And you just said, well, I have to go width of m, so I just pick an amount to go up. It doesn't matter how far up I go. And I say that that point right here would be the point 0 because the x-coordinate, I'm putting it right at the origin. And I went up m. Now I didn't go up 4, 5, or 2, or 3, or whatever. I went up m. So the coordinate is 0m. And then the length is twice. So if this is m right here, this would be 2m right here. So my x-coordinate would be 2 times m, and my y-coordinate is 0 because it's actually on the right on the x-axis, so the y value is 0. And now this point, this is the one that messes most people up. To find the x-coordinate, you just go straight down, and oh yeah, that was 2m. And then to find the y-coordinate, you go straight over, and that one we already found was m. So the coordinate of this vertex here is 2m, comma m. All right, let's look at another example. In this one, we have a triangle. It has legs of length s and length t, and it's a right triangle. So it doesn't matter where you put s and where you put t. And again, we go up to s. We're saying this is s on our y-axis. Well, it doesn't matter if your s is bigger or less than t because we don't know. And t is going to be on the x-axis. Now again, you have to write the coordinates of the points. 0, 0 is easy enough to do. We place it at the origin. This would be 0 for the x value because it's going over 0, and up to s. So the s value is s. And then the other one, the other coordinate right here is t because we went over t on the x-axis and then up 0. Again, unless you know there's a right angle, don't use both axes like we just did in this one because we knew it was a right triangle. It told us that it was a right triangle, so we're able to use both of them. We can't do that unless we know that there's a right angle in it. Okay, so in this example, we're going to put a square, and again, I'll use 0, 0, with length 4p in the coordinate plane and give the coordinates of each vertex. So draw a sketch on your paper, see if you can do that, and then check what your answer looks like compared to this answer. So does yours look like this? You got your x and y axis, one of our points is 0, 0. One of our vertices would be over 4p on the x-axis and up 0. One of them would be 0 for x and 4p for y, and then the last one would be 4p, comma 4p. It's a square, so each of those, the coordinates of that last vertex, the x and y coordinates should be the same. Okay, so if you're actually doing a coordinate proof, it makes sense to choose coordinates that make the calculation simpler. So if you're going to find the midpoint, use multiples of 2, so that when you divide by 2, it'll be simpler. So make it be as simple as possible when you're going to use variables. All right, so here's an example. We have a rectangle, and we want to show that the diagonals are congruent. So the first step is to draw your sketch, and I already put it here. So we've got, this should be A0. We've got 1 point at 0, 0. Now I picked that I'm going to let this be A. I just made that up. You could use x and y if you wanted, but that might get confusing with the x-axis and the y-axis. So I just called this point A, and I'm going up 0. And then I called this B on the y-axis. And then this point over here would be A for the x-coordinate and B, because I go down to find the x-coordinate, oh yeah, that's A, and over to find the y-coordinate, and that's B. All right, so this is the point AB. Now, I have to prove that those diagonals are congruent. So step 2 is to position the figure in the coordinate plane. Did that. Now I have to do step 3, write a coordinate proof. So let me draw these in. Here would be PR and here would be SQ. If those are the same, then I will know that I've proved that the diagonals are congruent. To show that they're the same, you have to use the distance formula, which says that x1 minus x2 squared plus y1 minus y2 squared. And we need to do that for 2 times. So for D1, I'll do it for PR first. So the x-coordinate here is A, and the x-coordinate here is 0. So A minus 0 is A, so I get A squared, plus the y-coordinate is 0, and this one is B. So I'd have negative B squared. So I get the square root of A squared plus B squared. That's when I did PR. Now I'm going to do it again for SQ. So A minus 0, x minus x, is A squared, plus B minus 0 is B squared. So again, I get A squared plus B squared. Now, no numbers, just variables. But this expression is the exact same as this expression. Exact same thing. So then I know that the 2 diagonals are congruent then. All right, so that's as hard as it gets. They don't get any harder than that. And if you have any questions, please let me know, and I'll help you out. Thank you very much, and have a great day. Good luck on your worksheet.